I want to
Yeah.
continue from where we stopped. The last class was we used ultrasonic sensors, right, to control an LED, and I also gave a task. Only few persons were able to do it. Which I don't know why the others refused to do it, right? But I just hope that we all know how to do that because it's gonna uh, help us today. We are going to be programming, writing some programs, and the idea from the task I gave is going to help us out. You guys will see what we'll do today. All right, so I'll start by bringing out the Arduino. Of course, you know this is the center of whatever we are doing. So I'll be using this, right? Then I'll be using a new component today, as in a lot of new components though, but this is one of it. I've not used this before in the class, but I'll be using this today. This is actually called a breadboard. If you look at the tag that came alongside it, it's written there breadboard small. That means we have a breadboard big, we have a bigger breadboard, right? Depends on the one you want to use. So if you search here, breadboard, you're going to see different types of breadboards, right? That you can use. This is a longer one, as you can see. As you can see, this is bigger than that. So it depends on what you want. So I'm going to be using the smaller one. Now, this is basically like an extension, right? It's like an extension. It creates room for multiple ports where you can connect your components or whatever, or supply, right? You can receive, you can supply. You understand? So these 2 points at the top that is labeled positive and negative are called the supply rail. Yeah, the supply rail basically. So you can actually supply power to this board from these two rails. And if you notice, when I kept my mouse cursor on one of the pins, a green straight line popped up and all that line was highlighted. So it tells you that this line is continuous horizontally. That means if you plug anything on this first pin, you can definitely get it from this last pin because the current flows like this, right? The same thing to this point, right? That's why you see every hole here highlighted, tell you the current flows horizontally. Now, if you come to this point, the current on this point flows vertically. If you notice, the green line highlights vertically, and it only affects these 5 lines here. It doesn't run across them to this. It stops here, starts here, stop here. There's a demarcation on this board here at this point, right? So when you plug anything here, you can get it anywhere on these other holes and stop here. It's similar to this point. You can plug here and get from this point. Plug here, get from this point. So these are just like the terminals, basically. I call this the supply. Just get the logic. This is similar to this first one, right? This is similar to this first one. They conduct horizontally. They both conduct horizontally. So that's just the idea here. I'm doing this because I want it to be I want the work or the connections we're going to be doing to be very explanatory, right? So uh, I want us to make use of it. At least you can also get used to it. So when you're working in real life and you have you don't need to make connections like that. Scatter. This is similar to what we call a variable board, right? I don't know if you've heard the term motherboard before, though. It's a very common word. That board you see there, where you get to make plug-in components and connect them together, right? That's just a permanent board, right? But this is a temporal one. When you plug on this, you can easily remove it. You just fix them in, but anytime you choose, you can just pull them out, right? So this is a temporal board you use in connection. So that being said, let me move on to bring out other things we'll be using, right? So we're also going to be using what we call a motor driver, right? Like I said, we'll be using a motor driver to run these motors. We won't be connecting them directly to the board. We need a motor driver that would control them, tell them, you understand, the increment and the decrement of the speed at which they should run and all that. So we'll be using a motor driver. And the motor driver we'll be using is called the L293D motor driver, right? The L293D motor. We have different motor drivers in the market, right? And anyone that suits your application, you can get that. But for in this case, we just have, I think on Tinkercad, we have just this, right? This is the one I've mostly worked on Tinkercad. So we'll be using this. Although in real life, the L293D motor driver, it's not really like this, right? It basically has three bridges, right? Three bridges, and can actually connect. It has four ports for motors, where you can connect four motors, two stepper motors, and I think two servos and the rest. So it's basically kind of different from this, but they work similarly. If you get to understand this, when you get the L293D motor driver in real life, you actually understand how it works, just with a little guidance, right? So basically, this is how it looks here on Tinkercad. So I'll run you through that. And also, we'll be making use of the motors, right? We'll make use of the motors. So I'm going to bring out two gear motors. Let's just use two gear motors. Then I will show you how to actually make it four. All right. If you want to use four here. So gear motors. All right. Just type gear motors. Of course, you have it here. So I'm going to bring it out. Okay. Then I'll rotate this so it will be a little bit, Then I'll copy this and paste it so I can have two, because I just want to use two. Okay, so I'll just align it here. All right, I think that's okay. Okay, this should be fine. All right, so the first thing I'll be doing right now is to bring out a power source, right, that I can use to power all my components here. And of course, we've been making use of a battery so far. So I'll bring out the battery also, right? And I'll adjust this to face this way. Okay. All right. Now, I said this in my previous classes, right? I don't know if it's the first one. I think it's the first class, that the power source should actually be the last thing you connect. So in real life, if you're building your system, you should always connect the battery last. But it's because this is a software, right, that it doesn't really start working until we simulate. So we can just connect everything, and it is when we simulate it gets to power itself and start working. Right, but in real life, please, you don't connect the power and work on your device, right? The power should be the last thing you're sending in. You should always make your connections, cross-check them for any errors you've made before powering it, because some of these devices can easily just go bad when you send in a wrong supply, or probably you've connected it wrongly. Let's say you connect the positive to the negative, and when you have a breach of positive and negative, you know what happens. Spark gets to happen, or it causes a short circuit, right? And that can damage your system. So basically, we might leave out the battery for now, and we'll just work on it as if we're working on the real life system, right? So let's see the pins that the motor driver has. So the first pin here is written enable. Let me enlarge this. Okay. So the first pin here is the enable 1 and 2, right? That's the enable 1 and 2 pin. Now, this enable 1 and 2 pin is basically used to control the speed of the motors, right? The first motor you're connecting to this pin, right? Now, each motor has two terminals, positive and negative. You can see them here, positive, negative, right? So this is meant to control the speed of this particular motor, right? It's meant to control the speed of this particular motor. Now, each terminal of this motor is connected to separate pins on the motor driver. If you take note of what you're seeing on the screen now, this second pin is saying input 1. The next one is saying output 1. So for an input, there's a corresponding output. That means when the input receives signal, it sends it to the output, right? So input 1 and output 1 are basically connected, right? Now we have the ground, GND, of course, that's a negative voltage, ground. We have output 2. So definitely there should be an input 2 since there's an output 2. So this is an input 2, right? So input 1, input 2. This is the input 1. This is the first, this is the 1, this is the 2, right? So if you're saying this should be on and this should be off, the motor turns in that direction of the one where you have the one connected, right? But when you switch it and you said the negative should be on, and this should be off. Indirectly, you know what happens when you switch the terminal of a motor, you know what happens, it changes direction. So that's basically what is happening there. When this is on, the motor goes in that direction. When this is off, it goes back. When this one is on, this is off, it goes backward. So that's just, we will try it and we'll see what happens. We'll see it, we'll simulate it and we'll see what happens. So this is power 2, right? So this is a power pin. We send in power to the motor driver, definitely, right? So we'll be sending it through, we'll be using the battery to connect it. All right, other pins at the top, we have power 1, right? So we are powering the first part of the pin. You know, we have two motors, right? So this is 1, this is 2. So we are powering the two motors. So this is power 1 for this, and this is power 2 for this one, right? So input 4, definitely there's an output 4, right? For this other motor now, right? Then we have the ground, definitely the ground, right? Then we have the output 3 and the input 3, right? For the two terminals of this motor, right? Then we have the enable 3 and 4 for this motor. That's to control the speed of this motor. Now, the input and output pins are basically, that's the in, you can see the input and the output. Yeah, they are basically used to just turn on the motor, right? You are turning on the motor to tell you the direction it should run towards. If you're turning on this, let's say you're saying in 1, let's say we connect this to in 1, that's the positive, and we say in 1 should be on. We're trying to tell the motor to run towards that direction, right? But make sure that, just know that when you're putting a speed, or you're giving in 1 or in 2 it's a speed, you should definitely, you're putting it on and you want it to run, definitely you have to enable a speed value, right? It's just like you putting on your car, you've not pushed your gear, right? You've not pushed your gear and you're stepping on your acceleration. The car is not going to move. It will just keep on firing, right? So that's similar to this. This is just like the acceleration, right? But you have to what? Give it what? You have to put it on first. You have to put your gear before you step on this. So this and this goes together. If you put this on, or you give it a speed value and you did not put any of these in pins on, right? The car won't still move. It's just similar to, okay, I put on gear and I don't match my acceleration. I just, leave it like that. The car won't still move. So it's similar. They work hand in hand. The acceleration must be worked on. The gear must also be worked on. So that's just a simple explanation of the whole thing. I'm just trying to summarize it. So when I'm connecting, you will know why I'm doing what I'm doing. All right. So let's start with the connection. So the enable pins, that's the speed control pins. Like I said, we have two enables, one for the first motor, the other for the second motor, right? Now, these pins are basically connected to what we call the PWM pins. I explained those pins in my last class, if you were attentive enough, because we connected, I think, the echo pin. Yeah, we connected the echo pin to the PWM pin. I told you why. That the PWM pin are responsible for what we call modulated signals, right? Modulated output signals. So the speed basically is just like an analog signal. Is a continuous signal, right? So since we need a continuous controlled output signal, we make use of the PWM pins. Please take note, right? Take note. We're going to be connecting the ENA, that's the enable pins, to PWM pins. And of course, we have 6 of them, right? We have 6 of them. We have the 3, we have 5, we have 6, we have 9, 10, 11, right? That's basically the pins. So we're going to use any of those 2 pins. We're going to be connecting our ENA and enable 1 and 2, enable 3 and 4 to any of those pins. So I'll start by connecting my enable 1 and 2. So I'm going to use pin 3 for that. Please, you can join me in doing this, so we won't waste much time. So connect this to pin 3. Okay, good. Now I connect the next enable to, I'm going to use pin 5 for that. That's also a PWM pin. So I'm going to use pin 5 for that. Okay, before I go on, please, are you guys actually getting me? So far, has there been any confusion? So far? Please, I need your feedback. Are you all getting me?
Now,
Can I continue?
yes, you can continue.
All
Yes,
right.
Yes, you
we are
can
good.
continue.
All right, that's good. Thank you. Okay, so
Yeah.
the next pin, I've connected my enable 1 and 2 pins, and I've connected enable 3 and 4 pins, right? So the next pins I'll be moving on to is the input pins, right? So we'll be connecting the input pins. The input pins, like I said, is just used to put on the motor, tell the motor what side it should run to. So we'll be connecting the 4 of them. So I'll connect, let's start with the in one. The in one, basically, you can connect them to any digital pin. Since you just want them to come on and go off, you know that's a digital signal. That's a digital signal, right? Just to come on and go off. We said digital signals have 2 states. So we'll be connecting this to the digital pins. I'm going to use for iron one. You can choose any pin you like. It mustn't be the exact one I'm using, right? You can choose any, so long as you're following the procedures. The ENA and the enable pins have to be on PWM. Oh, sorry, I was logged out. Let me share my screen again. Okay, can you guys see my screen?
Yes.
All right.
Yes, sir.
All right, good. So the next pin is the output one, right? So since I've connected my input one, I'll connect my output one to the first pin of the motor, right? You can see the way I'm connecting I'm making my connections. I try to make them aligned. You would notice that the alignment line is always there when I'm connecting it, right? So as to ensure that my connections are straight and neat, right? But when I gave the task the other time, I noticed some guys were just crossing their wires and like that. It doesn't make your wirings neat. If you're working on practical real life device or real life systems, it's very good to make sure your works are very neat, right? It gives you this sense of satisfaction also, right? And during fault finding, it's also very easy. It is also very, you don't need to start struggling looking for how you connected this to this. So long as they are carefully arranged, you can easily just pick out the faulty one and do whatever it needs to be done. All right, so the next pin is the ground pin. So of course, we know we should have connected this to our negative, but we've not connected the battery yet. So I'll leave out the ground pins first. So let's go to output input 2, right? So let's connect input 2. So I'm going to be connecting this to another digital pin. Connect this to another digital pin. So I'm going to be using, let me use pin 7, or 4 is free. Let me go to 4. All right, so there it is. Pin 4. So my input 2 goes to pin 4. And my output 2 goes to the second terminal of my motor, which is the negative terminal, right? So I'll connect this to my motor. All right, fine. So what's here? Power 2. Of course, we've not supplied the power yet, so I'm still going to leave that out. That'll be the last thing I'll do. All right, so the next thing I thought power also, I'll leave that out. The next pin, input 4, right? So I'm going to connect this to a digital pin. So let's take this to, let me use pin 8. Pin 8 for that. Input 4 goes to pin 8. Output 4. Oh, I need to reduce this so I can actually see the motors. All right. So output 4. Let's take output 4 to the negative. All right. Now, this is basically what is happening. If you notice the way I'm connecting it, this was 1. This was connected to 1, right? If you click on it, you'll see it. It was connected to 1, right? And the second one was connected to 2. Now, I'm making that same arrangement here so the motors can actually move in the same direction, right? So I made this 3 and I'm making this 4, right? So 3 comes before 4, right? Just like 1 came before 2. So 1 and 3 are the top, 2 and 4 are below, right? So that's basically logical. It's basically logical. If you do it the other way, it would still work, but you have a different rotation. So you can either change it from the way you connected it at the terminal, or you change it in your code, right? You can change the programming in your code and it will still work fine, right? Fine. So this is ground. I'll do that. I'll connect that where my power is connected. This output 3. So I need to connect input 3. So I'll connect this to a digital pin also, similarly, like the input 4. All right. I'll take this to 7. Right. I'll take this to 7. All right. Good. What's next? Output 3. Okay. So I'll connect this to my motor. All right. So that is it. Okay, if you notice, I was connecting most of my in pins strictly on plain digital pins. Now, my reason for doing this is subsequently you might want to add other sensors, as the case might be, or other devices, right? And you might require making, because the PWM pins are special pins and we don't have much of them. We don't have a lot of them on the Arduino. We just have about 6 on the Arduino Uno. But on other Arduino boards, like the Arduino Mega, right, is quite bigger than the Arduino Uno, right? The Arduino Uno is basically like the smallest, right? The Mega has about 53 digital pins or thereabout and about 16 analog pins. You can compare that to what we have here. This is about 14 digital pins and 6 digital analog pins. So you can see the number is quite massive, right? So if you're working with the Arduino Mega, of course, you have a lot of these pins at your disposal. All right, so let's get back to business. Now the next pins are the power pins, the negative, the grounds, and the power, right? So I'll be connecting the batteries, right? So I'll supply the battery terminals to my breadboard, right? Just like an extension, I said it earlier. So we can easily connect every other thing to it. If I don't do this, definitely you're going to see a lot of wires just joining. Everything will be, connected directly to the battery, and I don't want that, right? So that's why I'm using the breadboard. So the negative now goes to the negative. I told you this is my power rail, so I'm using my power rail to make this connection, right? So positive goes to the positive, negative goes to the negative. So I can supply everything from this point, right? From this point. Right now, for this top part, I can easily also connect it here, but to make my work a bit neat, I'm going to supply these points, these 2 supply points at the top. I'll supply them from here, from this one, right? Just by taking the negative down to this negative and the positive down to that positive, like this. So I've looped it, right? I've looped this point to this point. That's just what I've done. Right? So very easy. So that I can easily just connect the ground here to my negative, connect this ground to negative, then my power goes to positive. Now, sorry, I skipped that part. The rating of the motor driver actually, the real L293D has a large voltage range, actually, a large input voltage range. I think it ranges from about 5 volts or 4.5 volts thereabout to about 36 volts, right? So you can actually take voltages that start from around that rates that are between 4.5 volts to about 36 volts. So you can see we are making use of a 9-volt battery, so it should work just fine. All right, so I'll connect the upper part too for the second motor. Power 1 goes to my positive, ground goes to negative, and the other ground goes to negative. So that's just it. I've succeeded in connecting everything that needs to be connected. You can see how, of course, yours might be neater than this, it's fine, but at least you can see how the wires, the connecting wires are straight and aligned, right? So yours should look, if it must look better than this, right? Do it better than mine, that would be even much more accepted. But let it not be less than what you have here. Okay, so do you have any questions on the connection so far? Because I want to move to the coding right now. We are done with the connections. Oh, sorry, one last thing. Please, we need to power up the Arduino also, right? We need to send our power to the Arduino also. So positive to our V in, right? As we've been doing. in the previous classes, positive to VIN and negative to GND, right? Negative to GND. All right, all right. So that's it. That's it. So any questions on the connections that I can just easily, since we are not much, I think I can take questions and we'll do. Oh, I think the first link would expire soon because it's meant to run for 40 minutes each. It's free Zoom. So I think it's best we should just log on through the second link now and continue, right? So not just get shut out at the middle of something important, right? So please just log out and immediately log in through the second link. I dropped two links, right? So you can just join basically what's happening there. Is that clear?
Yeah, it is clear now.
All right, thank you. Okay, so I think we'll move to the coding part. The last person is here to join us. I think that's Mr. Ofatso is here to join us. But hopefully he will join us soon, but we can't wait because we are working with time. All right, so let's go to the coding part. So we click on code, change this from blocks to text because we are actually programming, typing our programs, right? So remove all these codes there. These are just by default. So remove all of it because we need to type everything afresh so we understand what we're doing. Remove this comment. So I'm going to just leave that first comment right at the top. Okay, so far we've been learning how to write codes, right? So writing code. Okay, I have a chat. No code. All right, that's fine. Thank you, Mr. Kojo. All right. So the first thing we do when we're writing the code, is to declare your variables, right? So you need to declare your variables that you want to make use of. So the oh, I think Mr. Anfatso is having a problem joining. He just sent me a direct message. Sorry, please let me reply him. So, oh, okay, okay. Log out and join again. Okay, I think he's having a problem joining. All right, so the first thing we'll do is to declare the variables, right? Of course, you can see where we've connected several pins on the Arduino. So we are going to be declaring all these pin numbers we've connected on the Arduino alongside any other variable we might want to use at the end of the day. But since we don't actually have any variable to use, right now, I just want to show us how we can control the motors, but subsequently you can decide to create variables as the case might be. So I'm gonna declare my enable pins. So I'll say enable. So I'll just, instead of writing 1 and 2, I'll just use A, right? Enable A. So the A should cover for the first motor because 1 and 2 they are just trying to tell you this speed control is for the first motor, right? The two terminals of the first motor. So I'm just going to be declaring it as enable A. And for enable 3 and 4, I'll use enable B, right? So enable A, I used pin 3, right? If I'm correct, let's still confirm that. So this was enable A, right? So I connected, good. I connected 3. Then I think I connected enable B. Please don't forget your semicolon at the end of that line. All right, so I connected enable B to pin 5. All right, so please just assign yours to assign them to the pin numbers you connected yours to, right? Assign them to the pin numbers, enable A, enable B. So the next pins are the input pins, right? The input pins we connected. So I'm going to declare the input pins. So input 1, right? Input 1. Let's see where I connected input 1 to. Okay, this was input 1, fine. So I think input 1 was connected to 2. Input 1 was connected to 2. All right, so input 2. Input 2 was connected to, okay, just click on that wire, tells you where you're connecting it to, okay, to 4. All right, so 4. Okay, so input 3 input 3 is connected to, let's see, this is input 3. Okay, click on the wire. Okay, that's 7. All right, so input 4 is left. I think input 4 was connected to 8. All right, so that's basically it. Okay, I think Mr. Anfatso has been able to join us. Okay. Oh, not him. Oh, I think he's still struggling to join. Okay, that's fine. Hopefully, if he's not able to join, we'll have the video at the end of the day. I'll try and post it. Okay, so that's all for declaring. So we've declared the 6 pins we connected to the Arduino, right? So the next thing is to initialize them in our void setup. That is, we state what functions they are carrying out. So basically, they are all output pins, right? They are not sending data to the Arduino. Instead, the Arduino is sending data to the motor driver and telling it what to do. Oh, I don't know why Mr. Anfaso is currently having issues joining, but I thought you all joined with the link. Okay, let me repost the link on the group again. Probably he's still joining with the first link I posted. Okay, let me just repost this link. Sorry. Okay, so we initialize them. How do we initialize them? Of course, we state their pin mode, right? And state their output. Like I was explaining earlier, they are all outputs, right? So they are not sending data to the Arduino. Rather, the Arduino is sending data to the motor driver and giving it controls, telling it what to do, what pins to put on, what pins to put off, and the rest. So you know how we write our pin mode, right? Our pin mode function. Then we start by stating the enable A. Enable A is an output. They are all outputs, basically. They are all outputs, right? So just state them all as outputs. So I'll just copy this. Okay, someone just joined. Oh, or someone left rather. Okay. So input A. Okay, so let's go to inputs. Input 1. Okay, so we're gonna do that for every input. This. All right, let me just duplicate them as needed. Okay, so this will be 2. This will be 3. Don't forget, I said you can also replace this with the pin numbers, right? So long as you've assigned them to these pin numbers, instead of using the variable names which we used in declaring them, you can also use the pin numbers. But I gave you reasons why I prefer using the variable names, right? I gave you reasons why I prefer using the variable names because you can easily make adjustments to your code and it won't affect every part of your code. But if you use the pin numbers, definitely if you change a pin, you will have to go all through and change those pins. So I prefer using the variable name. All right, so that's all for that. We've stated our pin mode. So the next thing we are going to be doing is, okay, Mr. Anfatso has been able to join. That's good. All right, so the next thing we'll be doing is to control the motors right now, right? We'll be controlling the motors. Now, I'm just going to be doing 1 or 2 functions. I'm just going to be writing 1 or 2 functions and subsequently I'll give you guys tasks, right? Which you'll do and drop on the group. Let me see what you'll be able to do, right? So I'm going to be doing 2 directional movements, a forward movement and a backward movement, right? So let's start with the forward first. So like I said earlier, the ENA and EMB pins are responsible for the speed control, right? So since we want to control speed, we can't digital write it. We can't digital write the signal, right? Because we've been using digital write to carry out a digital output. That's when we want 2 states of output, high and low states, right? But right now we need a continuous output, right? A continuous output. And I gave us examples. I listed 4 functions that are very important in this our coding process, which are the digital write, digital read, analog write, and analog read. And I told us I explained to us those four functions. So for the the enable A and the enable B, we'll be using the analog write function, right? The analog write function, that's just like giving out a continuous signal, right? When the Arduino is giving out a continuous signal, you use the analog write function, right? So for the ENA and the ENB, we'll be using analog write to send out the signal, right? And this is how you write analog write, because this has to do with speed, right? We are not just turning it on and off. You understand? So analog write in brackets, what pin are you controlling? Let's start with ANA. Now, for forward, when you want your car to move forward, the both tires, right, have to be moving, right? The both tires have to move. So definitely we are going to be giving both ENA, both enable A and enable B speed. The both of them will have speed, right? So let's say I give my enable A speed. And what speed value am I going to give it? Now, another important thing is to note that we have what we call standard analog values. Now, these analog values ranges from 0 to 255, right? The standard analog values ranges from 0 to 255. So if you want to give a speed value, you can choose from that speed, right? You can choose from that range I just said, 0 to 255. So let's say I'm using my maximum speed value, which is 255. So I want my tires to move at the highest speed, right? Good. And I'll do the same for the second enable pin, which is the enable B pin, right? So, okay, this is A, sorry, and this is B. Okay, so I've told my two motors to move at high speed, right? As the maximum speed. That's just what I've done, right? I've told my Arduino to send out the maximum speed to my motors. Now, what's the next thing? The next thing I need to do is to turn on the terminal of the motor that should make it move in the forward direction. Now, let me write a comment there to show that this is for forward. This is a forward function, right? This is a forward function. All right, that's for the car to move forward. All right, so now for the car to move forward, I explained it earlier. Let me bring this up to this side again so you understand clearly. I explained it earlier and I said that your two motors, okay, let's say this is my forward, like this part is my forward, where the Arduino is right now, right, is my forward. So you can see that the red or the positive terminals are in front, right? So I'm going to imagine that is my forward. That is where I want my car to move towards to, and that's the forward point, right? And the backward should be where the negative side is. That's the car should turn back, should move backwards when I put on the negative pins. So my two red pins are input 1 and input 3. So if I want my car to move forward, I would have to put on the input 1 and input 3 pins. And my input 4 pin and input 2 pin would stay off, right? The 2 pins can be on at once, right? Because the tire can't move front and backwards at the same time. Can't move forward and backward at the same time. That's like impossible to happen. It only has to move either forward or backward. So for forward movement, when you're putting on the first pin, you put off the next one, right? That's just what we're going to do. And since this is just to put on or put off, we'll be using, these are digital pins, right? Digital signals. So we'll be using the digital write function, right? So we're going to write digital write in brackets input 1, comma, high, right? Just like the way we blinked an LED, right? Input 1, high. Now the next pin, I want to do mine, I want to follow mine, I want to arrange mine, right? I just want to write, I don't want to scatter the whole thing. So I'll do it orderly. So I will go to input 2. Now my input 2 will be off, which is low, right? So I go to the next one. My input 3 will be on, which is high. I go to the next one, input 4. My input 4, sorry, what just happened? Oh, okay. So my input 4 will be low, right? So I'm going to simulate this first. We'll see what happens. Then we'll now do the backward function, right? So let's simulate this. Let's simulate this first. So I'll click on start simulation, right? All right. Now I'm going to close this coding area so we can actually see what is happening. All right. So if you look closely, let me zoom this. Okay, let's look at one motor first because the screen is not wide to contain the two of them at this zoom rate. You can notice that, there is a value of the speed, that's 231 rotation per minute showing on the motor. And you can see if you look closely, although it's white and it might be a bit confusing, but if you look closely, you notice that those motor shafts are moving, right? They are moving in the direction of the red pin. That's the forward direction that I explained earlier. Let me show you the second one. So similarly, the second one is moving in that direction, right? It's moving in that direction also at 231 RPM too, also, right? So that's basically the forward. That's basically the forward. Now, if you want the motors to run backwards, all you need to do, okay, stop simulation, go back to your code, right? And you adjust it. So instead of 1 and 3 high, what you now have is 2 and 4 high. This is one way you can do it, or you can decide to switch the wires in your connection. When you switch the wires in your connection, this changes from forward function to backward function, right? Those are two ways you can do it. You can change it in your code, or you can switch the wires. But it's better you just work out everything in your code, right? So you don't keep changing wires as the case may be. So let's add a backward function. So let's say I want this forward to run for, I'm going to put a delay to tell it how, just like how we blinked an LED, right? I'm going to put a delay to tell the motors to run for a certain time. So let's say I want the forward to run for 5 seconds. The car should move forward, or the motor should spin forward for 5 seconds. And then I'm going to add a backward function. I will add a backward function. So when it spins forward for 5 seconds, it turns back and runs backward for 5 seconds. It changes, right? Changes from forward to backward and runs for 5 seconds. So that's how it's going to do. So I'll just copy this uh, to avoid typing this all over again. So the two enable pins will definitely have speed, right? They will definitely have speed. Then what next? My input one would go from high to what? To low, right? Because I want the car to move backwards. Then my input 2 would go from low to high, right? Input 3 goes from high to low. So everything changes. And my input 4 goes from low to high, right? And it should also run for 5 seconds, right? So that's just basically it. So let me simulate this and we'll see what happens. All right, so I'll close this. All right, so let's watch with one. So look at the first one. Okay, so although it's a bit confusing because it's white, so you have to look very closely to see what is happening. So it runs forward, and when it's 5 seconds, it changes, right, and turns backward. The only way you can carefully understand that is probably putting a function that would make it stop, so that you would see how it stops and now goes back or turns back, right? So let's add a stop function. So we'd notice when it stops and then goes back. So in between my forward and backward function, I'm going to add a stop function. Of course, you know what a stop function is: for the car not to move or the motor not to move. And that will be very easy to do. That is just by putting off everything possible. Put off everything possible. Put off your speed, put off your in pins. So instead of 255 now, I'm going to have 0 there. I'm going to change my speed values to 0. I'll change this to low. I'll change this to low. Right? So everything goes low. Now, even if I don't change this to low and I leave them as high, but so long as I've kept my enable pins at 0, it will still stop. Remember I said if you don't give it speed and you put it on, it will not work. If you give it speed and you don't put it on, it will not work. Right? So the two goes together. But I just want to make it easy to understand that everything would be off. Right? I just want to make it easy to understand that everything would be off. Right? So I'm going to simulate this now so you'll see what I'm talking about. So code goes back. Okay. So 5 seconds. All right. That's 5 seconds. It stops, right? And goes back. After 5 seconds, it goes back. Can you see that? It now goes back, right? Now it's showing you minus. If you look at the value on the motor, it changes from a positive value to a negative value. It stops. That's 0 RPM. It has stopped, right? Now it's going back and it gives you a minus, a negative value. That tells you it's going the other way, the opposite direction, right? That's basically a stop, a forward, how you write a forward, a backward, a stop function, right? So this is just a simple way to make your motors move.